So you'd like to run machine learning models without having to pay for MidJourney access. One of the ways you can do that is to run Stable Diffusion or Disco Diffusion or any of the other models through Google Colab. Stable Diffusion is the newest and probably fastest, maybe most coherent version of diffusion model. I still prefer Disco Diffusion for some things, but Stable Diffusion is probably the easiest one to use. It's much like MidJourney. So if you just look up Stable Diffusion Colab in Google, the first link will probably take you to a good Colab document. So a Colab is basically just modules of code that you can run from a cloud computer through a web browser. So this is Stable Diffusion with dynamite diffusers, I guess. So the way we work with this is we're going to you can read through it. Tells you a little bit about how diffusion works. You come down here into setup. You can run this. You'll get this warning message, just say run anyway. The first module we run just tells us what our GPU is. So I'm running a Tesla T4 with 15 gigabytes of VRAM. You're going to need at least 10 to run this model. So if you, for some reason, are running Colab and this is less than 10,000, you see we got 15,000 megabytes, you might have some issues. You can subscribe to Colab Pro, which will always give you a high-end GPU, but that costs money. So we're trying to avoid spending money. This should work. So now we're going to go through each one of these modules and just run them. So it says next you should install diffusers, so we'll run that. It'll take a few seconds. We'll run the next module, which enables external widgets. So we can use this notebook login. And now we can log in with our user token. So you need to accept the model license from Hugging Face. So if you click this link, it will take you to Hugging Face, create an account. You need to share your contact information to access this model. So you'll come down to access, read the terms and conditions, abide by them. Access repository. You're going to create a Hugging Face account, log in, do all this stuff. You'll have to confirm your email. Come back to this page and it will give you a checkbox where you accept the model and submit that acceptance. Then you can go back to your Stable Diffusion and come down to this next line of code, which is the notebook login. So you'll run this. In order to get that to work, you need to create a token in Hugging Face. So to get to your tokens, go to your user menu, go to settings, go to access tokens. And then here, I'm not going to click this, but you can copy, and it'll copy your token. And then when you run this module, it'll ask you for your token. You can paste it and then log in. So this is basically the model. We're going to run this, and it's going to install a whole bunch of things, not onto your local computer. It's installing it onto the cloud instance. So none of this actually runs locally on your computer. If you are interested in running any of these models locally on your personal computer, you can download Visions of Chaos for Windows. Visions of Chaos is a free piece of software that allows you to access all kinds of things, including text-to-image generation models, Stable Diffusion, Latent Diffusion, Disco Diffusion. It is a great piece of software. It is a little complicated to install and set up. If you want to run it on your Mac, there is a tutorial on how to install Stable Diffusion. Again, it's a little complicated, but if you look up Jacques Alomo Stable Diffusion Mac, there's a great tutorial where he runs through the process of installing Stable Diffusion on your Mac. Again, it's a little complicated. You have to install Homebrew, you have to install Python, some terminal stuff. I believe you run the model through terminal. So if you're not comfortable doing that, maybe just stick to the Google Colab, or pay for MidJourney, or pay for DALL-E or Stable Diffusion. Okay, so now we've run the pipeline. tells us everything is going well. Now it says, let's move the pipeline to GPU to have faster inference. So we're going to play that module. Okay, done. Using AutoCast will run inference faster because it uses half precision. I have no idea what that means, but we're going to run it. So by default, the prompt that comes with the model is a photograph of an astronaut riding a horse. This is sort of a famous DALL-E prompt. And so what will happen is over 50 iterations, it will generate an image. So it just generated that image for us. Let's change this prompt to a paper sculpture of a cat, volumetric lighting, say angry cat, volumetric lighting. There we go. So we're going to run that again. And you can see it's pretty fast. It only needs 50 iterations to get a decent image. These images used to take 30 minutes to run. When I started doing this 2 years ago, the image would not look anything like that. It would look much worse, and it would take 30 minutes to generate. That took 14 seconds. And here we have our paper sculpture of an angry cat. Love it. So there's a few more things you can do in this notebook. There's not a lot of control you have here, the way that you would have in the Disco Diffusion notebook. There may be other notebooks. I haven't looked too deeply. So you'll notice if I run this again, we're actually going to get a different image because it's using a random seed each time. So if you don't like the image you got, I quite like that one. But we can run it again with the same prompt and we'll get a different image. There we go. It's a different angry cat. And we can make any changes up here and run it again, and we will get our new image. So now we're going to do a sad cat. Yeah, that looks like a paper sculpture of a sad cat. It's beautiful. And again, as with any prompting situation, you can add more detail to get a more specific image. So we'll say a sad red cat wearing a cowboy hat. Bam. So that's the basics of how to do image generation for free, as much as you want, through Google Colab. There are some additional parameters you can play with here, and I'll get into that. But if you just want to generate images, that's all you have to do. You can save these, copy these, use them. The license for Stable Diffusion, I would recommend looking that up. I'm not a lawyer. I don't give legal advice, but I believe the license for Stable Diffusion creates all these images as public domain, so they are theoretically usable by anyone, but keep in mind that this model was trained on potentially copyrighted material, and so anything you create with it may infringe on copyrights. Obviously, if you type something like Batman up here, you're infringing on copyright, so be careful how you use it. You can, so here's an example. You can just roll down the Colab, and there are some more modules. So this one allows you to put in a manual seed. So if I run this prompt, I think this prompt must be loaded in here, prompt. And what makes this difference is it has a manual seed. And this is where you can assign a seed. So if I run this again with this same seed, it will give me the same image or something almost exactly the same because it's starting with the same pattern of noise. And the way that diffusers work is they start with random noise. It's basically a ridiculously advanced denoiser. So it looks at the noise as a very noisy photo of whatever you're describing and then tries to denoise it to create that photo. So this is using seed 1024. If I change this seed to 1025 or even a whole bunch of numbers and run it, it will give me a different image. But every time I use that seed, whatever number I put in, it'll give me that same image. So this allows us a little bit of control as we're making changes to parameters. If we want just slight changes, if we want to change the prompt but not change the image too much, using the same seed is helpful. So you'll see we have a different image here. Some seeds give better images than others. So I can change this to seed 20 and we'll get a different image. But it'll still be a red cat, a red sad cat wearing a cowboy hat, paper sculpture. And there are more or less infinite numbers of these images that we can generate. Some, again, are going to be better than others. That's not great. We'll try seed 512. That's not bad. 512. I think 1024 was a pretty good one. So we ran 1024 earlier, and we got a specific result. We should get that result again. There it is. So one more thing you can do, at least in this Colab notebook, number of inference steps, you can change this. So again, we're using seed 1024. So it's going to generate this cat, but you can see here where it says 51. This was 51 iterations, or steps is really what they are. They're steps of inference or iterations. This little module here will run that same prompt, but only with 15 steps. So you'll see this will give us a much lower quality version of that same image, but it'll come much faster. And if you look at the difference, this in terms of looking like a paper sculpture, this has nice, sharp, clean lines. This is kind of messy, doesn't look so much like it was made with paper. You can also boost this up. So if we bring this up to something like 150, and I'll speed this up so you're not having to wait. So you can see this image has a little bit more detail. The lighting on the face is probably a little better. There is sort of a law of diminishing returns. If I boost this up to 1500, it's not going to look much different. 50 is generally a pretty good number of iterations. You're not generally going to get much better quality than if you boost it up past 50, but sometimes you will. So another thing you can do in this Colab is you can create a grid. Number of rows, number of columns, that'll give us 4 images. And again, we're going to bring our prompt in here. And here's our, we get four images based on that one prompt. So each one's using a different seed. And some of these are better than others. Paper sculpture of a sad cat wearing a red cowboy hat. Yeah, that's just a cowboy hat. That looks more like a chicken. That looks more like a chicken too. So I don't know. If we run this again, we'll get different results because it's putting in random seeds. But that's how you can make a grid of images if you want a few to choose from. And then finally, you can change the height and the width. So if you want something other than square. The only thing here, though, is these need to be multiples of 8 because of the way the model works. And one of these numbers should be 512. So if you want a wide image, use a height of 512 and a width of whatever. So we can make this a width of 1024, let's say. If you want a tall image, though, you could do 1024, but make width 512. This clearly will limit you for your resolution, but that will prevent it from creating weird repeating patterns throughout your image. If you'd like to upscale these after you generate them, you can use like ESRGAN or one of the AI upscalers, which there are tutorials on YouTube. You can find out how to do that. So we're going to make a tall image, 1024 by 512. I like that one, but his leg's very long, which is kind of funny. Just below that, in case you're interested, it gets into some details about how Stable Diffusion works, how latent diffusion works, how image synthesis works generally with diffusion models. And if you're really an advanced user, I know we have some engineers who might be watching this, scroll down, how to write your own inference pipeline with diffusers. So there's a pre-trained model. You can come in here, you can work with that. It has some instructions on how you can sort of get into the weeds and really play with the code. So you can sort of really customize things. I hope that helps. Enjoy. Happy prompting.